MSc first year students. Welcome to the online class. Hello, I am Mahendra Janrao. I am here to teach you the subject of MSc first year, the CHP-110 Fundamentals of Physical Chemistry. Fundamentals of Physical Chemistry. It is also called as Physical Chemistry Part 1. So, this is important subject of your MSc first year syllabus, CH-110 Fundamentals of Physical Chemistry. Now, in this subject, there are two sections. First, we see the syllabus here. So, it contains two sections. Section first contains 4 topics, and section second contains 5 topics. Okay. So, this section first, we are going to commence this section first initially. So, this section first contains 4 topics. First topic is thermodynamics. Second topic is change of state. Change of state. Third topic is quantum chemistry. Third topic is quantum chemistry. And fourth topic is chemical bonding. So recently this topic added in the new syllabus, chemical bonding. Okay. So these are previous topics. These were also in previous syllabus, thermodynamics and quantum chemistry, change of state. So these topics are already from last syllabus. And this one is the newly added topic, chemical bonding. Now section second contains 5 topics. Okay. Section second contains 5 topics. In this section second is a chemical kinetics. We have to study whole kinetics, chemical kinetics in the second section. So chemical kinetics and reaction dynamics. Reaction dynamics. This is your second section. So this second section contains 5 topics. First is rate laws. You have to study all the rate laws in the first topic. Second is the kinetics of complex reactions. Kinetics of complex reactions is the second topic. Third is the molecular reaction dynamics. Third topic is molecular reaction dynamics. And fourth topic is the enzyme catalysis. Fourth topic is enzyme catalysis. And last topic is molecular thermodynamics. Fifth topic is molecular thermodynamics. Molecular thermodynamics. So this is the total syllabus of subject fundamentals of physical chemistry, CHP-110 of your first semester. MSc first year, first semester, physical chemistry is first subject. CHP-110. It contains 2 sections. First section contains 4 topics. First is thermodynamics. Second, change of state. Third, quantum chemistry. And fourth, chemical bonding. Section second contains 5 topics. We have to study the chemical kinetics and reaction dynamics in section second. So rate laws, first topic. Second is the kinetics of complex reaction. Third is molecular reaction dynamics. Fourth is enzyme catalysis. And fifth topic, last topic is the molecular thermodynamics. Okay, so we have to start with the section first. And first topic of the section first, that is thermodynamics. Okay. Thermodynamics, we have previously studied it in 11th standard also. Thermodynamics. Thermo means it is already related to heat. Okay, so thermodynamics, first topic of your section first, that we have to study is thermodynamics. Thermodynamics is related to thermo means it is related to heat, and dynamics means we have to study the reaction mechanisms and reaction dynamics in this topic. So thermodynamics means, how can we define the thermodynamics? Thermodynamics is the branch of chemistry that deals with the study of energy changes. Study of energy changes in the form of heat. So we know that the energy of universe is constant, but the forms are changing. Okay, so energy of total universe is constant, but the forms of energy continuously changing. Means that mechanical energy is converted to electrical energy converted to heat energy. Some other forms of energy, wind energy is converted to electrical energy. Different forms of energy are continuously converting into each other. So energy changes. We study energy changes, but those involves heat. Means those energy changes involves heat. We study all these energy changes in thermodynamics. So how can we define thermodynamics? Thermodynamics we can define thermodynamics, the branch of chemistry or branch of science simply. It may be studied in physics, so it's what a branch of. It may be considered a branch of science or not in chemistry. So it's a branch of science that deals with the study of energy changes in the form of heat. So this is thermodynamics. We have to study different energy changes, different terms. So before starting the proper topic of thermodynamics, we have to understand some basic things about thermodynamics, some basic concepts, some basic basic terms that used in thermodynamics that we have to study one by one. So if you know all these terms, then it may be easy to understand all the complicated topics or other topics of thermodynamics easily by knowing the proper basic terms. Okay, so we know that these are very simple terms, but we must know these terms before starting the proper syllabus, because if we don't know what is meant by system, if we don't know what is meant by system, what is meant by surrounding, what is meant by boundary, what is meant by homogeneous system, what is meant by heterogeneous system, what is macro state or state variables, what is intensive properties, what are extensive properties. So if we don't know these basic terms, then we are not able to understand the proper concept of the thermodynamics. We have to study these concepts stepwise. Okay, so see the system. System is what? It is a thermodynamic system. Thermodynamic system means what? It is anything under consideration. Anything under consideration or anything under observation is called a system. Okay, anything under observation. If you are observing any reaction in a beaker, so this is our system. Anything under observation. We are observing that. That means that is a system. So, for example, reaction in a beaker is called as system. Why it's called as system? Because we are observing that. So anything under observation is called as system. So reaction in a beaker is a system. Suppose second term in thermodynamics that we have to study is a surrounding. Means suppose we have taken a reaction mixture in a beaker. This is our system. Okay. And anything outside the system means air, light, or other things that outside the system are called as surrounding. Anything outside the system which has some effect or not, but these outside the system, those things which are outside the system are called as surrounding. Third is a boundary. As we saw, this is a system. We have observing any reaction in a beaker is a system. Anything outside the system is a surrounding. And the thing which separate system from surrounding. What is that thing? This glass of the beaker, walls of the beaker. These are the boundaries which separate system from surrounding. Surrounding from system. So anything which separates system from surrounding or surrounding from system, that is called as boundary of system. That is called as boundary of system. So these are basic terms. System. Anything under observation is called as system. Anything outside the system is surrounding, and the thing which separate system from surrounding is a boundary. Okay. So this is some basic terms. Now we have to see the types of systems. Okay. Next we have to see the types of systems. So in thermodynamics, there are different types of systems such as open system, closed system, isolated systems, open system, closed system, isolated system, adiabatic system, isothermal system, homogeneous system, heterogeneous system, microscopic system, macroscopic system. So these are different types of system which are considered under thermodynamics. Okay, see one by one. What is open system? Open system, the system which exchange both energy and matter with surrounding. Okay, with exchange both energy and matter with the surrounding. That is open system. It is open system which exchanges both energy as well as matter. Second is a closed system. Closed system is what? It exchange only energy with the system, with the surrounding. Okay, the system which exchanges only energy and not matter. Okay, exchanges only energy and not matter. That is closed system. Isolated system which neither exchanges energy nor exchanges energy, neither matter. Which doesn't exchange energy as well as matter. So that is isolated system, totally isolated. Next is adiabatic system. Adiabatic system is what? The system which do not allow energy changes in the form of heat. Does not allow to enter heat into the system or does not allow to remove the heat from the system. So that is adiabatic system. Isothermal system is what? The system in which temperature is always constant. Iso means same. Thermal means heat. So same temperature, the system which maintains at same temperature, that system is an isothermal system. As we know that we have done a practical of TYTSC. There is kinetics practical, chemical kinetics practical, in which we have taken water bath and we kept our reaction mixture in that water. For what purpose? To attain a constant temperature, to maintain constant temperature. So that reaction mixture when we keep in a in that water bar, so it attains the temperature of that water bar by exchanging heat. So exchange of heat takes place in the this isothermal process, isothermal reaction, and temperature of the system remains constant. So this is isothermal system. Next is a homogeneous system. Homogeneous system is the system which is present in only one phase. Single phase is there, so it's a homogeneous system, such as pure water, pure alcohol, any solid system. So homogeneous system which do not contain other phases. Only single phase is there, that is homogeneous system. Next is a heterogeneous system, which contains more than one phase. So 2 phases, 3 phases. Okay, so more than one phase is present in the system, then that system is called as heterogeneous system. Okay, heterogeneous system. See, microscopic system. Microscopic system means the component of the system, such as molecules, ions. So these component of the system, if present in very small quantities, minute quantities, then that system is a microscopic system. And if present in very large amount, then that system is called as microscopic system. That is macroscopic system, large amount. Microscopic means present in a small amount. Okay. So see, macroscopic system is identified by macroscopic variables. Okay. So variables, if any system is there, that system has some particular variables, and these variables are called as thermodynamic variables. These variables are called as thermodynamic variables. Means if we want to understand any system, or if we want to measure some system, any system, then we have to consider some parameters, and these parameters are nothing but thermodynamic variables. Which are these parameters? If we observe any system, then we have to observe its parameter in measuring pressure. Okay, so this is one of the parameters we call it thermodynamic variable. Pressure, volume, temperature, amount of substance. So all these variables, thermodynamic variable, or they are also called as state variable. What is called as state variable? I'll tell you. Thermodynamic variable or state variable. Pressure, volume, temperature, a number of moles, or amount of substance. So these are the parameters by which system is identified. So these are state variables. What is state of system? State of system. The state of system is what? If these variables, state variable or thermodynamic variable, having fixed values, pressure, volume, temperature, if they have a fixed value, then it is called as a state of a system. Okay, this is particular state. We say if it is an initial state, and if this parameter change, so P2, V2, N2, if these parameters change, then it's another state, second state, or we say final state. Final state. So these are state variable. State variable are important to understand the system or finding out the state of system. If they have fixed values, then that is called as particular state of system. If it is having fixed value, then we call it initial system. And if these values change, but they are fixed, then it is final state of a system. So initial state means state is identified by state variables, and these are the state variables by which we can identify the system. And these variables are related by one famous equation. The equation is ideal gas equation. So these variables are related by this equation, related in each other by this equation. We call it ideal gas equation. It is important in our thermodynamics. So we will see it later. PV is equal to nRT. As we know of this ideal gas equation, how it is derived, and the uses of this equation, because it is important in thermodynamic concepts. Various concepts that we have to study, we have to use this equation, ideal gas equation. So these are some basic terms. And another important term is extensive variable. Extensive variable, the value of these variable depends on amount of substance. These are extensive variables, and another intensive variables. What are intensive variables? The value of which does not depend on amount of substance. Suppose see extensive variables. Extensive variables is what? The variable whose value depends on amount of substance present. Okay, value of which depends on amount of substance present. Okay, which are the extensive variable? An example is mass. Okay, how is extensive variable? Mass is extensive variable. Another volume is an extensive variable. Okay, extensive variable. Why is it called as extensive variable? Energy is extensive variable. Extensive variable means which the value of which depend on amount of substance present. Now, amount of substance present. If mass, we have taken 1 kg of any substance. Okay, 1 kg is what? This amount. So this is variable. Mass is a variable. 1 kg. So it is why we call it extensive variable, because we have taken 1 kg mass. Okay, if we change the amount of substance, instead of 1, we have taken 2 kg. Means this variable changed. Okay, so extensive variable changes because it depends on amount of substance. Okay, and instead of that, see another example of intensive variables. Intensive variable. Okay, so intensive variable. Suppose intensive variable viscosity or simply the boiling point of substance. Okay, boiling point of substance. If we have taken boiling point of 1 ml water, what is that? Boiling point of 1 ml water is 100 degrees Celsius. Okay, instead of that, we have taken 10 ml water. 10 ml water. What is the boiling point of this 10 ml water? It also boils at 100 degrees Celsius. Okay, what is the if we instead of we have taken 100 ml water, 100 ml water. What is the boiling point of 100 ml water? Boils at the same temperature. Means boiling point is the property which does not depend on amount of substance present. We have changed amount 1 ml, 10 ml, 100 ml, but the property does not changes. That means the intensive variables are the variables which does not depend on amount of substance present. So amount of substance does not depend on amount of substance present. Hence these are intensive variables. And extensive variables whose volume, as we instead of that we have taken 1 ml water. Okay, so volume is 1 ml. Instead of we taken 10 ml water, volume changes. So this property changes. If we taken 100 ml, volume changes. So this property depends on amount of substance present, and these properties such as boiling point, viscosity, pressure, temperature. So these properties does not depend on the amount of substance present. But these properties are called as intensive variables. These are extensive variables. Okay. So this is the difference. Sometimes they ask the difference of extensive variables, intensive variables. See some examples of extensive variables. Amount of substance present depends on amount of substance present, such as mass, volume, energy, heat capacity. With intensive variables, viscosity, pressure, temperature, boiling point, melting point. So these are the properties which depends on amount of substance, does not depend on amount of substance. Next concept, basic concept, we have to study as a state function and path function. State function and path function. State function, path function. What is state function? State function whose value depends on initial and final state of the system. Initial and final state only. Does not depend on which path it follows. That function is called as state function. Okay, that function is called as state function. Another is a path function whose value does not depend on initial and final state of the system, but which path follows. Which path follows, that depends on the path followed. So it is called as path function. Okay, you have to see these functions in detail, state function and path function. Okay. State function and path function. Simply remember this time only. State function is what depends on initial and final state of the system. Path function is dependent on does not depend on initial and final state. It depends on path followed. Okay. So these are some basic terms you have studied in a